Well, good morning, everyone. My name is Dr. Ahmed Al-Kadi, and in this lecture, I'm going to introduce you to Matlab. Matlab is the software that you are going to use as part of this module to solve engineering problems and to apply all the different numerical methods that you are going to learn in the lecture. Let me just start by a quick introduction to Matlab. So Matlab is software that basically you can use it. It's a programming language with an interface that you can use it to solve different engineering problems, to write code, to develop programs or other applications, and many things like that. So it's a very popular actually programming language, Matlab. It's up there with other programming languages that you probably heard of, like C++ or Python. So it's very, very popular among engineers and scientists, and we use it a lot. So I think would be a very good addition to your knowledge, knowing how to use Matlab and how to think as an engineer or as a programmer, and how to use the different numerical tools to solve actual engineering problems. So this program can prove to you later on in your career that it's very, very useful, and it gives you an advantage with other with your peers and so on, with respect to programming knowledge and software knowledge. So the support material, basically, Matlab is a very well documented software, and if you go online, there is a huge amount of tutorials and whether video or written resources on Matlab. The main one that I would recommend here, this is Matlab Central. So if you go to Matlab Central, you can actually, this is a forum, user forum, where you can go there and you can create an account for free. And using this account, you have access to many resources like functions and other resources developed by other users within the forum. In the same time, you can, if you are doing some kind of program or you're writing some kind of script and you have an issue that you cannot find a solution for it online, you can ask a question on this forum and then you will get an answer very quickly. So it's very, very useful to do that. There is also here the link for the Matlab documentation. So again, if you go there, you will see the documentation for all the different functions and how to use the program, and all the different tutorials that are provided by MathWorks, which is the company that develops Matlab. You can use Matlab through the virtual environment in the university by accessing the virtual PC from your actual laptop. So you can do that and use Matlab, or you can download Matlab from the university software, or in general, even after you leave the university, you can always get Matlab for students by going to this link. So you can download it for free, you can have it on your laptop and just work directly. As for material like reference book, I mean, there are many books on Matlab. One of the most popular is the one here, Essential Matlab for Engineers and Scientists, with some examples similar to the ones that we're going to discuss in this introduction session and in the modules, the tutorial sessions later on. So again, it's very, very well documented, and again, you can find many resources online. So this is the Matlab interface and the components of the Matlab interface, but instead of just reading from the slide, I will go ahead and open Matlab, and we are going to discuss all the different components of the software. So if you go ahead and open MATLAB, so I have it open right here. So I have MATLAB 2020 A, but you can have a different version, that's fine. It's more or less updates in the functions of MATLAB, but with respect to the interface, they more or less all look the same. So what you have here, well, this is pretty much the toolbar or the taskbars. So you have here the home tab, you have the one for the plots, you have one for applications. You don't care for any of those two in general, so we just stick with the home tab over here and all the different tools within it. Over here in this bar, you have the directory, so you can open or browse for a specific folder where you are going to start working within. So right now you see the directory that I'm working in. All right, so it's selected over here. So this is the directory. Again, you can use the browse button to go to a different directory on your PC, that's fine. Now, since I'm in this directory, so on the left side here, I see the directory window. So this directory window over here, this one, so it shows me this is the current folder, which is the one here called intro session. This is the folder that I'm currently in, and it shows a list of all the folders and files inside it. So right now I have only these three files inside this folder, but pretty much this is a list of everything inside this folder. In the middle, if I click on it, it will be activated. This is the main window. This is the command window, as it says over here. So this is where I'm going to write and execute all the different commands in MATLAB. So this is the command window. All right. And right now it says like f of x over here. If you click on that, you can browse for different functions, but we don't use that in general, so we don't care about this. So right now you have these two arrows, and then I see the arrow here is blinking, so this means I can start writing a code. And actually, if you go here to the bottom left corner, it says ready. So ready means that the program is working fine and you can do whatever you want. If you are executing some kind of command while the program is running, you will see this status here. It will say busy. So busy means it's running, so you have to wait until it finishes running. On the right side over here, I have the workspace, and the workspace pretty much I can resize over here. Okay. So this is the workspace. So the workspace pretty much, it shows me all the different variables, that I already defined as part of whatever project I'm working on. So right now there is nothing inside it. All right. So this will show me a list of all the different variables, the name of the variable, the value of the variables, and other things as well. So how do you use MATLAB? Well, MATLAB is very straightforward. It's like you using a calculator or something like that. So you can come in the command window, and then you can write whatever you want. So for instance, you can use it as a calculator. So you can say 1 plus 2. So you can just type 1 plus 2, and then you click enter. So once I wrote 1 plus 2 and I click enter, so it says here, you see answer is equal to 3. So automatically, or by default, MATLAB defined a variable and called it ANS, like short for answer, and it saved the output of my operation. So this is the operation that I executed, which is 1 plus 3, and I got the output, which is 3, 1 plus 2, sorry, and I got the output, which is 3, and it was automatically saved in this default variable. So any output or any value, it needs to be saved in a variable. So that's why MATLAB automatically created this default variable answer, ANS, and saved the output. Now, if I go to the workspace, you can see here that now I have this variable ans, all right? And you can see the value, you can see the minimum, maximum, median, and so on, all right? You can see other definitions from like the class of the variable. So this is double because it's a number, all right? So this is a double number, and of course the value is 3, and the minimum and maximum and median or any other values, they are all the same because this variable includes only one value. Actually, if you double click on this variable, you will get this other window, and this other window, it looks like an Excel sheet. It's very similar to Excel sheet. Actually, you can copy things from Excel and paste them here. So you see that this variable here, it's 1 by 1. So it's kind of an array or a matrix, but it's 1 by 1. It's one column, one row by one column, because it contains only one variable. And the variable value is saved over here, the value of 3. You can actually modify the value here if you want directly in this. So I can make it 305, for instance. And then if I close, you see over here it's updated. So again, you can use it as a calculator, so you can do any kind of operation directly. So what else? Like you can use, you have the typical operations. So again, using addition, 1 plus 2, 4 minus 5, subtraction, division, you do the slash, 4 divided by 6, for instance, you get the value, and multiplication. So you just need to do the asterisk here. So 5 by 2, for instance, you get 2, and so on. And you can keep going, doing any kind of operations. And of course, the operations can be larger than that. So you can say, let's say you can open parentheses, 50 plus 2.5 divided by 2. Again, so you can keep doing that. This is fine. And every time you will get the value and it will be saved. Since now we didn't define any variable, so it's the output or the answer is always saved in this default variable. If you want to clear this window, because now we wrote many things, if you want to clear this window, you can click, you can write CLC. So CLC will clear the command window. So if I click CLC and click enter, so now I clear the window, and then I can start on a clear screen if I would like to do that. So in general, we don't just write 1 plus 2 or whatever the operation is directly. Typically, we use variables and then we do operations on variables. So what does this mean? So let me show you. So first, let me clear also this. I want to delete this variable that I have here in the current workspace. So you can do that by going directly and on the variable and do left click and say delete. Or you can come in the command window and you can say clear, and then you say the name of the variable. Or if you just want to clear everything, you can just say clear all, and then it will clear everything inside the workspace. So here you go. And then I can click CLC again just to clear the window. So let's do the operations by defining variables. So let me define a variable. So I would like to create a variable. I will call it x equal to, and then I will save inside it a value equal to, let's say 10. So if I click enter, so again, I have here the new variable x equal to 10. You will notice here, now let me define another variable. Let's call it y, for instance. You can call any any variable, you can call any name, but you have to be careful. Any name that you, for any variable in Matlab, it needs to start with a character, a letter, not a number, and it shouldn't have any spaces in the name. Okay. So let me call this variable y again, and y I will save a value of 5 and click enter. So again, so now I have a variable called y. Now also with respect to the naming of the variables, Matlab is case sensitive, meaning I can define another variable, capital Y for instance, and I can say capital Y is equal to 360.5, something like that, and I click enter. So you have here small y and capital Y, all right? So it's case sensitive. So you notice here that whenever I write any command, I get this, like the command is rewritten. After I click enter, it's rewritten. So I say y equal to 5, I get y equal to 5. I say y equal to 360.5, I get this again. So this is called the echo function. Okay, so this is the echo function. So whenever I write something, it shows it. If I don't want this to happen, so when I say x equal to 10, you need to put a semicolon at the end of the command. So after I write the command, I put a semicolon. If I put a semicolon, that's it. The command will be executed and I will not get the echo feedback from Matlab, which is actually what we typically do. So what we typically do when we write commands, we always put semicolons at the end of the command lines so that I don't get an output here or this echo in the command window. So now I have all these variables. You can of course define other variables as well, but using these variables you can go ahead and start conducting operations. So I can say, for instance, x plus y. Now of course if I click enter, I will get the output here because I didn't put a semicolon. All right, and the output for x plus y, because Matlab now will execute x plus y, all right, which should be 10 plus 5, 15. And then this value of 15 need to be saved somewhere. So since we didn't say where to save it, it will create, as we said before, the answer A and S default variables, and it will save it inside. So here you go. So instead of that, maybe I want to compute x plus y, but I want to save it in a variable z. So I say z is equal to x plus y. So now I have the variable z. All right, so these are some of the operations, again, that you will have here in the slides. So this is for addition, subtraction, multiplications, and division. All right. What else you can do? Let me clear here the window. You can, if you want to do power, so let's say if I want to say, for instance, z is equal to x to the power 2. All right, I will not put the semicolon because I want to see the answer right away. So if I do that, so here you go. So x is equal to 10 raised to the power 2, so you get 100. So this is the operator. Okay, this is the operator for the power if you want to do a power. All right. So these are all variables. These are all single variables. How about if I want to define a vector? How about if I want to define a vector? So we have two types of vectors. You have a row vector and a column vector. So if you go to the slides, so this is how you do it. Okay, this is how you do it. So you have a row vector. So basically a bunch of numbers, okay, in one row. Column vector is a bunch of numbers in one column. So how you do that? Let's say, let me clear all these variables again and clear the window. So I will call it x, a vector x. And then if I want to define a vector or a matrix in general, an array, I do square brackets. So you do square brackets. And then inside the square brackets, you need to put whatever the values inside this vector. So maybe it's like 10, 2.5, 3, -6, -6, I don't know, 20. So that's it. So this is a row vector. So I have all the values. So this is a row vector that contains 5 values. and just by putting a space between each value, so that's it. So this is a row vector. All right. So I can put a semicolon to suppress the output, and then I click enter. So right now you see here x again, it's double because all the values inside x are double. And you can see here the value. So you have all the values that we defined, and it shows here the minimum value, -6, the maximum value is 20, the median is whatever, and so on. If you double click on the variable again x, you will see here again in this window, you can see that it's 1 by 5. So this is this variable x is 1. It says here x. This is a 1 by 5 variable because it has 1 row. It's a row vector, and it has 5 columns because it has 5 values over here. Again, you can modify the values right away in this window. So if I close that, so that's it. You have all the values for x like a row vector. You can do the same if I want to make a variable, let's say y equal to, I want to make a column vector. So again, let's say that I'm going to use the same values here. So if I want to make it a column vector, you need to do a semicolon after every value. So a semicolon here means that first I put 10, then semicolon means the next line. So semicolon in Matlab means the next line. So in the next line or the next row, put 2.5, the next row, put 3, the next row, put -6, and so on. If I click enter, so now I have y, again I have the maximum minimum. If I open y here, so now it says it's 5 by 1, so 5 rows by 1 column, and you see the values here are in a single column. So this is a column vector compared to the x, which we opened before. So if I open them side by side, so again, this is the y variable, and this is the x variable, which is a row vector. If I want to make x variable, if I want to make the x variable a column variable, that's easy. You can just say, let's say x, the new x is equal to the previous x. So take the previous definition of x and do transpose. How to do transpose? You just do a quotation mark like this. That's it. So if I say, so this is what I'm saying here, I'm telling Matlab that take x, transpose it, and save it again in x. So if I do that and I click enter, so what happened if I opened x again? So now x has been transposed, so it became a column vector. All right. So this is how to do the transpose. Now let's say that if you want, let me do a transpose again just to bring it back so that it become a row vector again. So now I bring it back to become a row vector again. So now we have x is a row vector, y is a column vector. So now what if I want to do something with these values in x? So let's say that, for instance, I want to get this element, like the 4th value in x. So what you do x. If I click x and click enter, so you will get all the values of x. So it says x equal, and it will show you all the values in x. But if I want a specific value, so I do x, I do parentheses, and then I need to specify inside the number of the column and the number of the row. So in this case, I want row number 1, column number 4. So I just say 1, comma 4, and click enter. So now I get the -6. So now I'm trying to get a specific value inside this vector. So that's it. So you specify the value of the row and the value of the column. And then you can do operation on that. So I can say, for instance, x row 1, column 2 or column 3 multiplied by 5. So this means you will get this value of 3, row 1, column 3, and then multiply it by 5. And if I click enter, so I get 15. All right. So that's pretty much how you use the values inside the value x. Now let's say that you did a mistake and you say x 3, 1 instead of 1, 3. So now you are saying I want to get the value in the third row, first column. Of course, x doesn't contain a third row. So if you do that, you will get an error. All right. Now, when you get an error, if you read an error, it will tell you what you did wrong. So it says here that the index in position 1, meaning this index, this value that you put here, exceeds the array bounds. And it says must not exceed 1. So Matlab is telling you what's the problem. It's telling you that this has 1 row, and the value that you put here exceeds this. So then you see the mistake, and then you can correct your mistake. All right. How about if I want to, for instance, I want to take all the values in x and I want to raise them to the power of 2. So what you do, again, you say x to the power of 2 and you click enter. You see, if I do that, you get an error. So the error it says the error using this operator. Why is that? It says incorrect dimensions for raising a matrix to power. Check that the matrix is square and the power is a scalar. Otherwise, to perform element-wise matrix power, and this is what we want to do. So we want to raise each value inside this matrix or vector to the power of 2. Use dot and then the operator. So when I'm using a vector, of course, you cannot raise a vector directly to the power of square. I need to raise each element inside the vector. So here I don't say x and then the operator, the hat here operator for the square, for the power. No, I need to put a dot before it. So already Matlab is telling me what to do. So now if I do that and I click enter, so now you see all the values in x, these ones, each value has been raised to the power of 2. For other things, you don't need to. Like if I want to take all the values in x and multiply them by, let's say, 1.5, you don't need to put the dot syntax here. You just say x to the power of 1.5 and then it will multiply everything by 1.5, for instance. It's only for when you raise to the power, you need to put the dot. All right. What else? So this is for, again, these are all vectors. Now, what if I want to create a matrix or an array? The same. So if I can say x, let me clear all the ones that I have right now. Let me start from scratch. So I say x, again, square brackets. Let's say I want to create a matrix that's 3 by 4 or 3 by 2. 3 rows by 2 columns. So I just put the values that I have, let's say 12, 2.5, and then I want to get, so this is the first 2 values in the first row, because I have 3 by 2, so this means 2 columns, and then I do, again, the semicolon, and then I put the second 2 values in the second row, which is, let's say, 3.5, 6.9, the next one, negative 9, 0.2, sorry, negative 9. That's it. So if I click enter, so now I have an array. So again, if I come here inside X and I double click, you see here that all the values here for the array, and it says here that the array is 3 by 2. Is 3 by 2, and these are the values. Again, I can modify here and I can put another column or something like that, the same. If I want to access a specific value, let's say I want to get this 0.2, so this is in row number 3, in column number 2, and that's it. Now, in general, we are not going when we are doing operations or we are solving some kind of an engineering problem. Typically, this solution doesn't include like just a single operation or like couple of few operations. In general, it's I need to execute a number of commands, like lots of commands, in order to solve a problem. So in most cases, I don't use this command window because writing too many commands in the command window, it's not practical. So typically we don't do that. So instead, what we do, we write these commands in a script file. We write them in a file, script file, and we run the script file. So how do we do that? Well, this is from the home button. You see here the home button, you have new script, and then you can open an existing script and so on. So what you do, you click on new script. So if you click on new script, you will get this blank window over here. And in this blank window, pretty much this blank window, it becomes like similar to the command window. You just need to start typing commands. All right. So you say, like, for instance, x equal to 1, y equal to 2, and then you say z is equal to x plus y, for instance. And then what you need to do, you just need to say run over here, this button over here, you say run, or just you can click F5 as a shortcut, and you click run, and then this code will execute. Now, before I do that, of course, I need to save it first, because as you see here, it's not saved. So you just need to click save, and I will call it test script, for instance. And I click enter. Now you see here in my folder, now this has been created. You see here test script.m. So this is called an M file. So an M file is a file that includes the code for that I've written. So this is called an M file. So if I double click on it again, here it is. Now if I run it, here you go. So if I run it, automatically this will be executed into sequential order. So x equal to 1, done, y equal to 2, and then z is equal to x plus y. So this was summed, and then because I don't have a semicolon over here, so I get the output in the command window. And if you look in the workspace, again, these variables has been defined in the workspace. So this is pretty much how we do it when we write a script. This is how we do everything from now on. This is how we are going to do it. Okay, so let's write script, for instance. Let's write script that will plot a quadratic function. Let's do some plotting, like let's plot a quadratic function. So how we do that? Well, typically when you start a script, you need to start by defining, by putting like maybe what is the script for and who wrote it and so on. So what if I want to write something like a comment? So if you want to write a comment, all you need to do, like a comment line, it will not be executed, it's just a comment. All you need to do is to put the percentage mark. So if you put a percentage mark at the beginning of the line, that's it. So automatically you see that everything I write afterward, it became a green color. It has a green color. So this means it's commented and it will not be executed. So here I can say, for instance, this script is used to plot a quadratic function. Quadratic function, of course, which is y equal to x square, if you don't know that. All right. Then you can probably say written by or author, and then you can put your name. You can say date, you can put the date, all right, and so on. So you can put any comments here regarding the script, because again, once you write a script and then you come to this script after 1 month or something, you will not remember if you wrote stuff inside the script like x equal to 1 or y equal to 2, you will not remember what the script was doing. So that's why it's a good practice that you need for programming, that you always need to comment everything to make it clear. So now you do that. Then what you need to do in general, once we start a new script, typically we would like to clear everything, because if I'm going to execute a new script and if there is by any chance some other variables that are already predefined in Matlab, this can cause a problem in my code. So it's a very good practice that you always start your script by saying CLC to clear the command window, clear all, so this is to clear all the variables, and then you can say close all, this is to close any windows, like if you have figure plots and other things open, it will close them. So this is common in any code that we write, that we typically put these commands in the beginning. So again, let's put a comment to say what these commands do. So these commands are used to clear the command window and existing variables. All right. And by the way, I don't need to put those next to each other like this. I don't need to put those after each other. I can put them on the same line. So how to do that? You can put a semicolon. So when you put a semicolon, semicolon means that this command ended, and then you can put one afterward. So basically here, if I go back here, remember we used to say x equal to 1, then enter, and then we say y equal to 2 or whatever, and then enter. Instead, I can write it like this, x equal to 1, semicolon, and then I can say y equal to 2 on the same line. So you can do this as well. Let's go back to our script. So right now, here I have CLC, clear all, close all. Again, always put a semicolon afterward. You will see that the Matlab is doing like some kind of underlining under the word all, and this zigzag line, it's like orange color. You can see it here also on the side, it's orange color. And if you go hover above this orange color, it says that warning found. Now warnings, this is a warning that means that your code will execute, but this is a warning. This is something that just be aware of, something that you may be able to fix. It's not an error or a problem. So if I go to this error, or if I go to this squiggly line, so it says here, using clear with the all option usually decreases code performance and is often unnecessary. So basically, and you can click on details and it will tell you basically what's the problem. So this is not a problem. You can keep it clear all, or you can remove the all and just leave it as clearly. Like basically you don't need to say all. All right. But let's keep it as it is, as all, that's fine, or remove it. In either case, it's not a problem. All right. Now, after I do that, okay, so the next thing that I want to do, well, I need to plot a quadratic function. So what does this mean? Let me open here. Something to show you. So we want to plot a quadratic function, and a quadratic function means that, well, I need some values for x, some values for y. Well, it doesn't need to be x and y. It could be whatever names that you have, but this is what we typically use to. So I have x and y, and I want to plot a quadratic function. So a quadratic function, it looks something like this, right? So that's a quadratic function. or let me actually put it exactly like, let me put the full axis, so xy. So typically quadratic function, something like this, right? So the quadratic function, it has the form of y equal to x squared. Well, of course, x can be multiplied by some coefficients, or this could be multiplied by another coefficient a, and it could be added to some coefficient b. But let's make it simple. Let's just say that we want to plot y equal to x squared. So in order to plot that, the command that we have in order to plot in Matlab, it's pretty simple. I just need to say plot. This is the command. And then I need to open parentheses. And then I need to specify the value for the x data. And then I put a comma and then put the values for the y data. That's it. But of course, I need first to define what is x and what is y. What are the values in x and what are the values of y? So in order to do that, well, what I can do first, I need to define some kind of range, because I will need to plot this function. So I need some kind of range to plot it from. So let's say, for instance, I would like to plot this function from -5 to 5. So I need to create a vector of values in x, okay, a number of values. I save them in a vector I call x, and then I will evaluate the value of y at each of these values and then plot this scatter of data. So how do we define a vector? So we say x equal to, then we open parentheses, and then we start putting the values. So I can say -5, and then what's after -5? Well, it depends on the resolution that you want. So let's say you want to do -4, -3, -2, -1, 0, and then 1, 2, 3, 4, 5. That's it. So now I defined a vector in x. But this seems to be, well, not practical. I mean, what if I want to do it like with a more refined resolution? Like I want to do each point 1, so -5, -0.4.9, for instance. So should I keep writing all of that? This will take forever. No, so instead of defining the vector like this, there is an easier way. So I can say define a vector x equal to, it goes from -5, and then I do a colon, and then I say to 5. So this means that you will create a vector. This will be a row vector that goes from -5 to 5. And then you can specify the step. So the step, I can say, for instance, 1. So this means define a vector x that will go, let me put spaces here so that it's clear. You don't need the spaces, of course, but just to make it clear here. So I will go from -5 with a step of 1 to 5. So that's it. This will create the vector, so instead of writing it myself. So if I want to go with a smaller resolution, I can just make the step, for instance, 0.1. So now I defined x. So now I need to evaluate the value of y at each of these values x. So y is equal to x to the power of 2. All right, but we said that since this is a vector, I need to put dot before the power. Otherwise, you will get an error. That's it. So this is pretty much it. Now, if I minimize this, if I run this code, so here you go. So everything has been executed, and you get your figure over here. So the x values here, you see the axis, it goes from -5 to 5, and the vertical axis, it goes from 0 to 25. So these are the values of y. Now, if you move here on the line, you will see that you can hover above the points and you will get the value of x and y. Now notice here this is at negative 3.6. The next point is negative 3.5, again because we went with a 0.1 step. You see that in the command window there is nothing showing because we commented or we put a semicolon after each command line. In the workspace, again, I have here the x and y variables that were defined. Now this vector for x, it's 1 by 101. So the size of the vector, it's a row vector that has 101 values inside. Now, of course, if I go by a step of 1 and I run it again, so you see here now, so now it becomes a little bit more not very smooth, the curve, because I'm going with big increments, right? So now it's less smooth. By the way, when you define a vector, if you have the step is equal to 1, if the step is equal to 1, you don't need to add the step part. So you can just delete that and you can say from negative 5 to 5. All right, so by default, the step increment is 1. But if you want another step increment, then you put the value here in the middle. So let's say 0.1. So close all here. Again, when we run it, what happens at the beginning, everything is cleared, all the variables are cleared. Close all will close the existing window here, which is figure 1. And then it will start executing this, this, and that. So here it closes and then it opens another one. All right. Now, in general, what we would like to do, it's for visualizing, it's better again to put comments. So I always need to put comments. So for plot here, you need to put a comment. So I say here, plotting the x, y data, for instance. Or I can say plot results. All right. For here, for instance, next to the x, I can say, I don't need to comment above it. I can just comment on the same line. So after this, I can put my percentage unit and I can say, for instance, define row vector named x. So here you go. So that's it. All right, so I commented. So it's very good that you do that. I can do the same here. I can copy and I can put it here. This is the, I can call this compute vector y, which is a function in x, right? So I can comment everything so that when I come back to my code, everything will be clear. Now, if I look at this plot here, if I look at this plot over here, well, it looks bland, like, I don't know, maybe I want to change the size of the font here. Maybe I want to put the labels, all right? So how we can do that? Maybe I want to change the line color. So if you want to change the line color here, well, there is one way that you can do it directly over here in this window. So you can do the edit plot, this over here. So you can select this arrow over here, and then you can select the plot, right click, and then you can change the color, you can change the line style, you can change the width of the line, you can make many things, you can put markers. So you can do many things. But instead, you can actually do it in your code. So the syntax of the command for plotting, like this one that I say plot x and y, this is the most basic format or syntax for this command. So in general, all the commands in Matlab, like for plotting or doing any other thing, they have like a short version and they have a larger versions or syntax if you want to add more attributes or more details. So here, the shortest thing that I need to provide just the value for x and the value for y. If I want to add more things, you just need to put comma. And then, for instance, if I want to change the color, you just need to put like these two single quotations, and inside I can say, for instance, dash. If I put this dash R, so this dash means that this will be a solid line, so the line style will be a solid line, and R means that the color will be red. If you want to make it, instead of a solid line, or you want to make it dash, then this is the syntax. You put two negative sign next to each other. All right, so let's try it like this. Let me run it again. So here you go. So it's a solid line with color red. If you want to put markers, okay, at each point, then you can come here between, after this, you can put O. If you say O, then you will get round markers. So if we do it, so here you go. So you get round markers. All right. If you want to have rectangular, triangular markers, you do this, the hat sign, the similar operator that you do for the power. And then if I run it, so then you get like those ones. Again, there are many options, but all of those you learn by experience. If I want the color line to be blue, for instance, so instead of R, I put B. That's a blue color. Green would be G, yellow, Y, black will be K. So K is what I use for black. So if I do that, then you get it black. Again, if I want it to be a dashed line, I do dash. So here you go. So again, these are all syntax that you learn by experience, all right? Or you can check the documentation to see what is the syntax for that. So let's make this, like, for instance, with markers with the color red. All right. Now, how about, so right now, okay, when I run this, okay, so I get one plot. I want to see the labels, like I want to put the labels, because the X data or the Y data represent something related to the engineering problem that I'm solving. So you need to put labels. So you can do that here. You can do it, of course, here from the window by selecting edit, and then you can modify and write it manually, or you can come here and you say the command is X label, straightforward, and then you put parentheses, and then you put X data, like whatever text that you want to write. The X data could be something else, like it could be like displacement, and the Y label could be like force or something like that. And then I can do the same. Let's always put a semicolon after any command. And for the Y label, let's call it Y data. And then if I run it, again, so now I get this, and I get X data and Y data. All right. So now we have, okay, we have this plot, but how about if I want to include another plot, like I want to superimpose another plot? So how can we do that? So let's say I want to make another plot, and here, after I plot this one, I want to make another plot, and this plot, it will be similar to this one, but maybe I can add two, like I take the values of Y and I shift it, I +2. And this plot, I will make it dashed color, for instance, and color black. So if I run this, so what I get is basically what I see now is this second plot. I don't see the first plot, because what happens is that each line is computed in sequence. And then when you come at this line, this has been computed, right? And then once this has been computed, then once you come to this line, what happens is this will superimpose the previous plot. So in order to avoid that, you need to put a command here and say hold on. So hold on, meaning that after you plot this one, hold on to this plot, keep it as it is, and whatever that will come next will be plotted on top of it. So if I rerun again, so now I see the two plots right here, as you see. Now, how about if I want to put a legend? Well, again, you can come here to the actual figure and you can go from this toolbar and you can say insert legend, or you can come here in your code and you say legend, you open parentheses, and then you say what is the name of the first plot. So let's say this is original or something, and then comma, and I say the name for the second plot. Let's call it shifted plot or something like that. And then if I run it, so now here you go. So you get the two plots, I get the legend over here. All right. So in general, again, you can modify further, like these commands, all these commands that I put over here. There are multiple more commands that you can use and attributes to change the format of your plot. Like for instance, by making this font larger, or make it like, for instance, instead of this, I make it Times Roman. So you can make many changes, like even the tick marks for the X data, and you can modify many things. You can modify the color for this plot to make it white like that. Size, font, like the plot size for the lines, you can make this thicker. For instance, you can go to the properties, you can make the line style width thicker, for instance, or lighter. So you can modify all these things manually, or you can write it actually as part of these commands. So we'll discuss this in a second if you want to look more into these commands, how to do it. Now, one more thing here is that typically we do when we write the code, in order to make the code organized, because it seems like all the commands are everything next to each other. Typically what you do is instead you can break it into sections. So you can break your command into sections, right? So how you can do that? So instead of a single percentage mark, if I put 2 percentage mark, you see what will happen here, that this thing will become bold, right? The font will become bold, and you have this line. So now it has been broken into section. So now it seems better to look at the code. Okay, now everything can be highlighted in a different color. So now it's broken into section. So here, for instance, this part, again, I can put another section over here, and this I can call it input, for instance. So this is my input, all right? And then whatever, you can put another one here for plotting, for plot results, all right? Okay, and you can put maybe another one here, and you say, okay, these are operations or something like that. So this makes your code easier to read, okay, because now you have headings and they look, they have like a bold style, and it's very easier now to look at it, all right? In the same time, this is very, very important, because once you write the code, let's say that you want to provide this code to somebody else. Well, if you want to provide the code to somebody else, well, you can go directly and send them this M file. But if you want to present it to somebody as a report or something like that, so you want to publish it. You want to publish this code. So how we do that? You go to the publish command you see over here. So this publish tab, if you click on it, and if you say publish, You see what happened here? So now the code has been executed, and what you get over here, this is an HTML output, basically. And over here it says the contents. So you have the contents of your different sections. That's why it's important. That's why it's very, very important that you include these sections in your code, because now you have this table of contents pretty much. So they clear the command window, input, operations, plot results, all right? So I can click on any one directly and it will go to the section. And then you have here this is pretty much the banner in the beginning of the code that says what the code does and who wrote the code and when and so on, or any other information. Then you have the different section of the code. So now this is published, and then you have the final output. Even the output of the code is shown over here. So the final output of the code is shown over here. So this is very good, because now I can just go ahead and print this. So I can print this published output. So I can say print, and I can print it as a PDF, for instance, if I want to give it to somebody else. And then I can save this. I say published script, for instance. I say save. That's it. So now you see here, now I have a published script, which if I can open it outside, here it is. So now I can give this to somebody else, and then they can check the code without going into Matlab. So that's why it's very, very important. That's why it's very, very important that you have these sections and labels, so that when you do the publishing, and this is something that you will need to do as part of the coursework, and all the problems that you are going to solve in this module and in the coursework, you will need to solve things in Matlab. You will need to write the code. You will need to comment everything in the code and organize your code in a way that's easier to understand. And then you will need to publish it in this form, and then print it as a PDF and submit it via e-assignment or any other online to be graded. So you need to do it this way. So basically, you will not submit an M file. You will submit the published version like this after you save it as a PDF. All right. So that's why it's very, very important to do this thing with the sections. All right. So now we have learned how to do all the basic operations in Matlab, which what you have here in the slides. How to create a row vector or column vector, or even to create a matrix or an array. How can you access specific elements inside a given array or a matrix. These are also some other procedure that you can do, like for instance, if you have an array and you want to get all the elements in row 2, so how you do that? So you put this column over here. If you want to get just the elements in column 2 or 3, again, there are some syntax for that. So these are all things that you can practice with. There are also many other commands, some of which that you are going to use later on in the tutorials to solve some of the problems that will be discussed in the lecture or will be given in the lecture. For instance, here, how to get the transpose of a matrix or a vector. I think we did that already. How to get the inverse of a matrix or an array, how to do that. What is the syntax for the commands, how to get the determinant of a square matrix, how to multiply elements in a matrix by a number, how to raise elements in a matrix or a vector to a power. We already did that as well by adding this dot before the powers operator. There are the basic functions as well, similar to the ones that you get, for instance, in Excel, like how to get the absolute of a value, the sum, to sum all the elements in a vector or an array, to get the maximum or minimum value or the mean, how to get the log of a number. By the way, in Matlab, when you say log, so by default log, this is returns the logarithm of the value x to the base of e, to the natural number e. So this is pretty much log x in Matlab is equal to len x. If you want log to the base of 10, then you need the command is log 10. So actually, if I go here to Matlab, like for instance, if I say log and then the value for 10, you will not get 1 because this is pretty much len 10. All right, so that's why you get 2.3. But if you write log 10, the command log 10 of 10, you will get 1. Now you have, if you want to get the square root of a value, again, you can just raise it to the power of 0.5, or you can use the command sqrt. With respect to trigonometric functions, sine and cosine and such, again, you just need to say sine and then specify the value between the parentheses. When you say sine, cosine, and tan, by default, the value of x need to be in radian. Now, if you have the value of x in degrees, then you should use sine d or cosine d or tan d. So again, if I go back to Matlab, if I say sine d of 90, then I should get 1. All right. What else? Yeah, with respect to defining functions, and this is something that you do a lot if you want to define a function in Matlab. So what we did so far, we just went here and we said y is equal to whatever, x square. Instead, sometimes the function can be bigger than that, and sometimes it could have like many symbols and you want to make it a symbolic function. So if you want to make a symbolic function, this is the syntax for it. So all you need to do, you need to come here, for instance. Let me comment this one over here, or let's keep it, that's fine. Then you need to create a function, you need to give it a name. So you can call it whatever you want. Let's call it, like, for instance, fun1. And then you say equal, and then you have the at symbol, and then parentheses, and then inside the parentheses you declare the name of the variables, declare the name of the variables in this function. So let's say it's just x, all right? And then a space, and then you write your equation. So for in this case, you can say whatever you want. X, let's do x cube plus 5 or minus 5 times x square plus 10, like any function. That's it. So this became a function here. And now, if you actually want to plot this function, so now if I want to plot this function, I don't need to use the plot command. There is an easier way, which is you can use the fplot command. So the fplot command, if I come here and I say fplot, if I can say fplot, this is the command, and then I need to specify the name of the function. So in my case, I called it fun1, and then you need to specify the range. Okay, the range for plotting. So let's say from -5 to 5. All right, and you need to specify, of course, if you want, the style of the plot. So let's say solid line, black line. That's it. So this way it will plot it. By the way, if I click here and if I run this code right now, actually I will not see this plot. The reason is when this code is being executed, it will come at this point. You will plot this line, fplot, all right? And then what will happen is that then for the next line, because you didn't say hold on, then plot XY will be done. So this will be removed. All right. So you might say, okay, let's move this hold on command over here. Well, you can do that. All right. Or instead, how about if we want two plots, two separate plots? So what you can do, if you want to create a new window for a new plot, you can just write the command figure. All right. So figure will create a new figure, and then it will plot this function. Then for the other plots, the one that we had from before, you can create another figure object over here, and then all of this will be plot inside. Now let's run it. So right here I have now two figures, figure 1 and figure 2. Figure 1 has the one that we plotted with the f plot, this cubic function, and figure 2 has these two plots. So this is how you create a new figure. Again, with this command figure, this is the shortest way to write figure. There are also other attributes that you can add by putting parentheses and writing different attributes. You can put attributes like to specify the location of the figure, like basically when it pops up on your screen, where does it pop up? Does it pop up here, there, there, there? So you can specify the location where it will pop up. You can also specify the size of the figure, because this you can control. So the size, the dimensions, the width and height of the figure. You can specify the color of the figure. So again, there are other attributes that you can add over here, but I'm not showing over here. This is for you to play with later on. There is something else also that you should be aware of. Basically, when you run this code, you could sometimes get an error. And although Matlab tells you what is the error, what type of error is it, so you might get, for instance, an error that tells you this function 1, there is a problem with it. But sometimes this error is not clear, and in order to understand why this error happened, you need to trace step by step, especially if you have a longer code, you need to trace step by step what's happening, all right, that's causing this error. So for instance, you could get an error that this x value, when this line was evaluated, was not there. Like x was not a value, it was like an infinity or like empty. It was not assigned. So in order to understand at what point did this happen, what you can do is debugging. So you need to debug your code. So how can you debug your code? Well, typically when you run your code, everything is run from the top to bottom, that's it. But if you want to stop during this running of the code at one line to check what's happening, you can do that. How you can do that? Over here on the side, you see these dash lines. In front of any line of code, you have these dash symbols. So if you click on one of those, you will get this red dot over here. So you can put red dots at any line. So you can put red dots, set previous. So you can put red dots at any line. Red dots here, these red dots, these are called breakpoints. So these are ones here. So these are called breakpoints. So when you put a breakpoint, meaning when I'm executing the script will run and then it will stop at the breakpoint. And then it will wait for me to tell Matlab to continue. So let's try it. So for instance, let me put the command window on the side and let me put this over here. So if I run it, so now the code has executed the first line and then now it's stopping here. That's why you see the green arrow over here. And then you can see that right now I don't have any variables defined in the workspace because I already cleared everything, so nothing is happening. if I want to go to the next line, then you just need to click on continue or F5. So if you click on continue, that's it. So now X has been defined, this line has been executed, and now you're at this line. Actually, if you hover with your mouse over X, you will see the value of X. So over here, I can see that X, it says it's 1 by 1, or 1 by 101 vector. So it's a row vector, and these are the values. You see some of the values inside this variable. And then again, I can want to continue. Okay, that looks fine. Then I go to the next one. Then here you go. Now Y is defined, already is defined over here. So then I can go, you get the sense now, okay, then I can go step by step and see what's really going on. I can put one, let's put another one here. So if I do that, so right now you see, you get your figure because this line has been executed, figure. And now if I go, if I put one here, then if I run it, so now you will get the first plot. This one has executed, and then if I click again, then you will get the other figure, and that's it. So this is how you do debugging for any code if you want to see the progression and what happens and what went wrong at one point. And then you can clear them just by clearing those, or you just can come here and say clear all. If you have many breaking points, you can do that. Alright, so this is how you do debugging in Matlab. And now let's also discuss something else. When you do debugging, you can actually do something else. Like instead of doing breaking points, you can run sections. So remember when we put the 2 signs for percentage, we created sections, different sections here. So the good thing we said about sections is that when you publish your code, you will get a table of contents and everything will be organized and clear, right? But in the same time, you can use these sections in order to run your code into run specific sections of your code. So if I say run here, instead of run with F5, if I say this, run and advance, so now I ran the first section and I advance to the next section. That's why this section, the input is highlighted. Then I can do again, and then now this is executed, and now I'm here. So I can run section by section if I want to do that. So this is again another way of doing debugging, by running section by section. All right. So that's why it's important to do this sectioning of your code. All right. So again, so when you write any of these codes, all right, so sometimes you use some of these commands, right, over here, and you say plot, and then you plot. And sometimes when you come back to your Matlab, sometimes you forget. You remember that you used fplot, for instance, or any other command before, but you don't remember the syntax. Well, there are many ways to find it. The easiest way, if you have used this command before, basically Matlab has a memory. Like anything that you type, any command that you execute is already present in the history of commands that you used. So if you write, for instance, you remember it's the command for plotting, but you just don't want to write it here from scratch. So you can just write P or PL, like maybe the first letter or the first 2 letters from the command. And then if you click the up button on your keyboard, then you can scroll. You can see over here, now you get all the history of commands that you have. So you can scroll until you get, okay, this is the command. Yeah, I remember. Let me do here X and Y. This is the command, and here you go, and then I plot. So this is a very good shortcut. You just go with the up button. You can go up the history and check all the commands that you have done before. All right. Okay, what else? All right, in the same time, let's say that you want to do a new command, but you haven't used it before. So the easiest way, of course, you can do the Google search. you will find it right away, or if you just don't have an internet or something like that, you can use always the F1 or help button over here. So if I click on that, you search the documentation. So you write how have the documentation. So if I search, for instance, sum, so here you get it, the functions for sum. So if I click on it, you get the documentation for the command sum. So you see here the syntax. There are several syntax for using sum. The shortest one is just sum A, where A is pretty much some kind of array or a vector. And then you get some examples. If you scroll down this page, you will get some examples of how to use this command. So this is one way of searching the documentation. You can also come here in the command window directly, and you can say help, and then you say sum, the name of the command, and you click enter, and then you will get here documentation again for the command, how to use it inside the command window. But of course, it's sometimes this is useful if you want to look it very quickly, but if you want to see it like in a formatted page, you should better check the help or check on Google, like online through your browser. How about if I want to get the average or the mean, but I don't remember what is the command? Well, you can type look for. So you can say look for, and you say, for instance, average, and then you click enter. And then Matlab right now, it's running. It says busy over here. You see it says busy over here on the corner. And right now it's running. It's looking through the documentation and finding all the commands that computes average. So actually this is the one that we use, mean. This is the command. If you want to stop it from searching, or if you have actually a code that's a long code, that's for some reason it goes into an infinite loop and it's not stopping, you can just click on in the command window, and on your keyboard click Control C. So if I click Control C, that's it. I break any operations that are being run. So I just interrupt it and I do a hard stop. So that's it. Mean, yeah, this is the one that I want. So if I click on it, then you get the documentation for mean, how to use it to get the average of a value. And at the end, you have the documentation for mean, so you can click here and you actually open it in the documentation or the help window. All right, so now that we understood all of the basics for Matlab, let's check other things. There are other things here in the slides, like how to do declare symbols, which is something that you are going to use in order to make differentiation or integration. Again, these are things that will come up in the tutorial sessions. How to do substitution, like if you want to substitute in a given function by a given value. Again, these are things that will come up later on. Clear and CLC, we already discussed those things. We discussed how to navigate through the command history and the semicolon to suppress the echo feature. Now, with that, okay, so now you have the basics of Matlab, but there are two basic things that we didn't discuss yet. These are the if statement and the for loop. So these are two of the basic stuff that you need to know in any programming language. So the if statement, or the conditional if statement, this is something that is basic when you are doing any programming, because typically when you are programming something, you always need to branch your code into two different ways. So you need an if statement. You say if this happens, do this bunch of commands, or if this happens, do this bunch of commands. So let's see how to use what is the syntax for the if statement. For that, let me comment these lines. I don't need those. Let me comment the plotting as well. All right, and then let's write a new code. Let's, for instance, have a code that for the input you define two values like A and B. Let's say 50 and b is equal to 15.64 or something, and another variable c, and let's say c 0. So we can say here for the operation, let's use the if statement. I can say, for instance, if c is equal to 0, so this is the command. I'm writing what I'm saying. So if c is equal to 0, then I want you to add a and b. So the result, let's call the variable result, is equal to a plus b. Else, the result, let's get a minus b, subtract the two values, and then end. So that's it. This is the syntax. You say if, you say the condition, all right, and then you specify whatever you want to do. If you have an else, then you write else. If you want to say if this did not happen, do that. Then this is then you write the bunch of commands that you want to execute, and then you need to end it always with an end. Now you see here that you have the red sign. Okay, this means there is a mistake, and the mistake is here. And if you hover, it says, you will see, it says a parse error at equal. So equal, this is not the valid syntax, because when it comes to the if statement, when you say c is equal to some, or something equal to something, you need to do two equal signs. All right, that's it. So you need to put two equal signs. So we can run this code. I don't need a semicolon here because maybe I just want this result to appear in the command window. I want to see it here. So I will not put suppress semicolon. I will just leave it like that. Let's run it. So here you go. Because c is equal to 0, this means I'm here. I'm satisfying this condition. So result will be a plus b. So 50 plus 15.64, so you get the result here. If you make c is equal to 1, something different, then you get the subtraction. All right, so it's just a simple thing just to show you how it works. In the same time, let's do additional stuff. So let's say that c, for instance, can be 0 or 1, or if the user puts something else. So let's say that if the user put 0.5, so you want, if c is equal to 0, you make addition, and if c equal to 1, you make subtraction. So if c is equal to 0, you make addition, that's correct. Else, if, so I want to say else if c is equal to 1, do that. And then else, so if c is not equal to 0, and its c is not equal to 1, then what should I do? Then this means that the user specified something more different than that, then perhaps print error on the screen. That's it. So now if I put 0 again, I get the addition. If I put 1, I get the subtraction. If I put something different, like 1.5, so that's always a good practice. Like whenever you are doing programming, it's always good that you cover all the possibilities that the user can do, because if you don't cover all the possibilities, you will get bugs and errors. That's why for any program, there is always an alpha version, a beta version, before it becomes what we call a stable version of the program. This means that all the bugs and all the holes in the code were covered. So covering the holes is pretty much meaning that you cover all the possibilities to avoid any errors. Sometimes in the if statement, sometimes it's not only a single criteria, like my criteria here is that just compare c, if c is equal to 0 or whatever. Sometimes it's multiple criteria, like I want to check many things. So how do you do that? Let's say if I want to say if c is equal to 0, and C is not equal to 5. So if C equal to 0 and you do double and C is not equal, this is the approximate equal, this is the syntax, is not equal to 5. So this is the syntax if you want to make a criteria that has like 2 criteria or whatever. You can add other criteria afterwards and whatever and so on. If you want to say or, so if you have an if statement criteria that if this happens or if this happens, do that. So for or, you just need to do the separator on your keyboard twice again. All right. So everything here for the syntax, like equal sign or whatever, it's always two things next to each other. If you want to see, if you want to say, for instance, bigger than or equal, so you can say that that's bigger than or equal 0. If you want to say less than or equal 0, you do that. So again, all of these syntax you can find in the documentation and more others. All right. So this is for the if statement, one of the basics. So this is how to use it. All right. The last thing that I will discuss today is the loop. How to do a loop in Matlab. Again, so the basics are all the operations that we discussed and the basic commands and the if statement, the conditional if statement, and the loop, how to do a loop. So in many applications, we need to do a loop. Like for instance, if I have some, let's say, vector. So let's create a vector, for instance. All right, and let's make it an array of values. All right. Actually, we defined an array before, so maybe I can look it up. Yes, here. So I can copy it from the history instead of me writing from scratch. And let's paste it here. So this is a 3x2 array that we defined before. And then I will make a for loop. I want this for loop to go through each of the rows and print the value in the first column. All right. So how we do that? So the syntax is for, all right, and then I need to say what's, so I can say, for instance, for I equal to, I is any variable, the thing that will keep changing. It goes from 1 to 3, so the number of rows 3. And then you need to close this for loop with an end. So I go from 1 to 3, all right? This I value will change from 1 to 3. If I want to print the value in the first column at every row, so I just need to say x, I, and 1. So this means in this loop will keep going from 1 to 3, and every time, first I will be equal to 1, and then this will be evaluated. Let's remove this the semicolon at 1 and 1, and then you will see the value in this element printed in the command window, and then it will I equal to 2 and so on. So if I run it, here you go. So I get 12, 3.5, negative 9, which are these values over here. It doesn't need to be I. This is just the common instance here because it's row, actually the row number, so you can just write row. So from row, from 1 to 3, do that. So the syntax in general, you say the start, okay, so you say you are going to start by 1 and the end value, and by default the step, so first you start by 1, then it goes to 2, then it goes to 3, so that by default the step is equal to 1, similar to when we defined a vector. If you want to change the step, then you put a value here in the middle. So I can say, for instance, from 1 to 3 with a step of 0.5. Of course, if I do that, if I run it, I will get an error because first row will be equal to 1 and then the program will print x1 and 1, that's fine. But then the next iteration in the loop, row will be equal to 1.5, and of course there is nothing called 1.5, so you will get an error. So let's see that if I run it. So here you go. So I got the first value 12 because the first loop was correct, but in the second loop the row was equal to 1.5, and of course there is nothing here that's you cannot say get me the element in the row 1.5 because the row need to be an integer value. So that's why you get an error here, and it's telling you that the indices of the array need to be positive integers. All right, they cannot be a fraction. Okay, how about if I want to print, I want to go through the rows and I also want to go through the columns and print everyone. So you can do what we call a nested loop. So I have a loop here that goes through the, let's make this one. So a loop that goes through the rows, and I can make another loop inside that goes through the columns, and I can call it for column from 1 to 2. And then I say end. So these are two nested loops. We have a loop that goes through the rows. So essentially what I'm doing here, let me write this array here. So the array that we have right now, it looks like this. 6.9, -9, and 0.2. So I'm saying go through the rows from 1 to 3. So, and then go through the columns. So what will happen? First, row will be equal to 1, so I will go to the first row, and then the code will go to this smaller loop. Then I will go from column from 1 to 2. So this means I will go through this element first, then this element, and then I finish this, then I finish the smaller loop, then I go again to the larger loop, which is now row is equal to 2, and then I go to this and that, and then I finish it, and then I go to the row 3. So this is how it works. So if I run it, so again you get all the values inside here the row, and this is not one anymore, this is row and column. So if I run it, you get all the element values. So this is what we call a nested loop. If you want to see how it works, like step by step, again, you can put, as we said with the debugging, you can put a breakpoint, and then you can run the code. You see, so right now you're here. If you hover above row, you will see that row is equal to 1 because this is the first iteration, and column is equal to 1. And then you are getting the value 12. And then if I say continue, then now row is still equal to 1, but now column is equal to 2. And then you get the second value here. And then right now the bigger loop, this one finished, then the other one goes, and so on. So now row is equal to 2 and column again is equal to 1, and so on. In the same time, let's say that you are inside the loop, but you don't want to go through all of this. Like, let's say that you, of course, inside the loop you can put many commands, like you can have a very big code. I'm just showing you just an example. How about I can say, for instance, if the value of x, like let's say this value over here, if this value is equal to let's say 3.5, or let's say, for instance, it's less than or equal 5. Let's do something different, something new. So if this happens, I want you to stop. I don't want you to keep going. You don't need to continue. Just stop this loop. Like, go outside the loop. Don't keep going. So you can just say break. All right. So this means that the code will keep executing until this criteria is reached, if this criteria is reached, then this code will exit, right? Which basically I have 12 and then 12.5, 2.5. So typically what should happen is that I will just get the first value and then it will stop right away. Let's try it. It didn't happen. All right, it didn't happen. Like we plotted, like what we see here, we seen 12 and other values are plotted, so are printed. So how come is that? Well, because break, it breaks the surrounding loop. So when you say break, you get out of this loop, but not the bigger loop. So actually this if statement, I need to move it and put it here. So that when it breaks, I break out of the bigger loop. So now let's do it. So here you go. So now I got 12, 2.5, and then I break because 2.5 is less than 5. So this is how we do these loops. There is another way to do a loop. This is called a for loop. There is another loop that's called a while loop. So it's the same. All right, so I can copy this loop, but instead of saying for, I say while. So instead of going from row from 1 to 3, I can say while row, for instance, is, or let's do it another way. So I want to keep going, but instead of breaking using an if statement, all right, instead of saying an if statement here to break this loop, I can say, instead of that, I can say outside while, and then I say the condition, while x, while this value is larger than 5, keep going, and then I need to say end here. So I will remove this if statement. So this code is very equivalent to this one. Over here, I'm saying that as long as, while pretty much, as long as the value is larger than 5, keep going, keep executing whatever is inside. But if this value reached 5, then you need to exit. All right. Now, if I run it, that's it. Again, you get the same. Output. All right. So there is sometimes you use while and sometimes you use for. Well, it depends on your preference, all right? But you have the two options. Let me also show you something here. When I say here, for instance, from row equal to 1 to 3 and column from 1 to 2, well, this is because I know that I have 3 rows and I have 2 columns, but sometimes, well, how about if the user is changing this input? Like maybe the input could be something else. Like it could be like this. It could be like 3 by 3. So if the user can change the input and the size of the array can change every time, well, I will not make a different code for every case. So I want to make a general code. So instead of saying from 1 to 3, all right, you can just say from 1 to whatever the size of this x, how many rows in it. So how can you say that? There is a command called size, and then you say size x, you say the name of the array, and then comma 1. 1 is the dimension. So dimension 1 is the row. So this, if I say size x1, this will return the number of rows in x. So actually, if I go here, you have x over here. This is the variable. It's 3 rows. So if I say here size, if I say size x, comma 1, I will get 3 because this is the number of rows. If I want to get the number of columns, I say size x, comma 2, then I will get the number of columns. So again, I can do this here to make my code a little bit general. So I say from 1 to the size, and then this is to 2. So of course, it's always better to make your code general and not very, very specific. All right. So this is how you can do this in this case. All right. You will get lots of practice once you start solving the tutorial problems and attending the tutorial sessions to see how we solve bigger problems. Okay. And then you will get better and you will learn more stuff. So that's it. This concludes all the basics that I wanted to cover today. Again, you can practice yourself, all right? Even with other modules, if you have any calculations or things you can, or problems that you solve in other modules, like for structure design or any of the other modules, you can actually write a script to solve it. So try from now on to use Matlab instead of Excel, all right, to practice more and to get better in it. I will also upload this Matlab Basics tutorial mini book to Blackboard. So this one, this book is very good, and it actually contains again an introduction, like similar to the things that we went through, like how to do the basic and common operators. It includes like some examples, some many functions if you want to look at. It includes some sample codes to solve some problems. Again, many examples. So again, you can use this, and but at the end, like I think by the end, from experience, this all depends on your, like, how much you practice working with Matlab, and anything that you need and you don't find, if you just go to Google, you just write Matlab, whatever that you want to find, your question, you will find it a clear answer somewhere, like at the top of the results in Google, and then that's it. You can continue working. So it's very well documented, and it should be a very smooth learning curve in Matlab. All right, so that's it. This concludes the introduction to Matlab. Again, it's very important that you attend the tutorial sessions with the TAs, ask questions, attempt to solve the problems from the lecture beforehand, and ask questions in tutorial sessions. All right, thank you for your attention.